Hey, flipped chemistry. Here we go. Chemical reactions. We're looking at what happens when something gets together with something else and changes bonds around and has a party. There's only basically four kinds of chemical reactions. We're going to go through those. We're also going to show you how to write out and read chemical reactions. This is something we've kind of been doing throughout chemistry so far, but we're going to take a moment and directly express how we use these equations. Okay, so writing, balancing, and using chemical reactions. Here we go. Chemical reactions show what chemical equations show what happens in a chemical reaction. Substances drawn on the left we call reactants. Substances drawn on the right we call products. And the little arrow that we draw between the reactants and the products we say yields. That's the yields sign. So A plus B yields C plus D. The A and the B are my reactants. They're what's reacting together. And the C and the D are the products. That's what is produced, what I've made. Alrighty? So here's an example. We have methane plus oxygen giving me water plus carbon dioxide. And we just went over naming rules, so maybe I should use the proper names for these things. We have carbon tetrahydride plus diatomic oxygen yields dihydrogen monoxide plus carbon dioxide. There you go. But we need to balance these equations. We can't just leave it like this, because if you look at this equation, you're going to say, okay, I've got a carbon over here and a carbon over there, but here I have 4 hydrogens and here I only have 2. What happened to my other 2 hydrogens? Did they just like pop out of the universe and they don't exist anymore? And then I've got 2 oxygens and 2 oxygens, but whoa, third oxygen, what happened there? Did another oxygen get created ex nihilo at that moment? No. So we have to obey the second law of thermodynamics. Nothing can be created or destroyed. And so we have to balance this equation. And we do that by writing coefficients, numbers before the elemental symbol, to represent how many of that thing is involved in the equation. So now when I balance this, I show that 1 molecule of methane is reacted with 2 molecules of diatomic oxygen to yield 2 molecules of water and 1 molecule of carbon dioxide gas. And then I look at this and I say 1 carbon, 4 hydrogens. 2 times 2 is 4 hydrogens. 2 times 2 is 4 oxygens. Here I have 2 oxygens, and here I have 2 more. Now it balances. See, so we always have to have things balance. And the balancing of equations is something that you're going to get a lot of practice with. So just for right now, know that you balance things using coefficients, and then you multiply and add and go back and forth until it all works. Sometimes you've got to go back and take a couple of drafts and multiply things up before it all starts to work, but eventually you will find success. Okay, here's an example again of something where something is reacting to form something else. In this particular example, if you notice, we have not just an arrow going in one direction, we have an arrow going back the other way. We'll get to reaction equilibrium near the end of the year, but I just wanted to show you that it's not always something that just goes in one direction. This molecule is breaking into 2, and then these 2 can react back together to form this. So this is what we call an equilibrium symbol. So to read this, you would say fructose is in equilibrium with dihydroxacetone phosphate and glyceraldehyde 3-phosphate. So organic chemistry, don't worry about all the funny names, but this thing is in equilibrium with this and this. This is still the reactant, these are still the products, but sometimes the products can combine and form the reactant again. Okay. Chemical equations, sometimes we also draw little arrows to show that something is released as a gas or that it precipitates out of the solution. Most of the time chemical reactions happen in a dissolved liquid state. Liquid plus liquid, and then sometimes it bubbles and gases come out, so we'll draw a little up arrow to say, hey, this was a gas that was evolved and it comes bubbling out of the solution. You can see that when you mix baking soda and vinegar, right? You could write that out and then say that it creates carbon dioxide gas with a little arrow next to it that says, and the carbon dioxide gas goes bye-bye. It leaves the reaction. And then sometimes you put a down arrow to show that this is something that precipitates out. So if you mix 2 liquids together and a solid forms and falls out of solution, and you have something now solid on the bottom of your reaction vessel. That's a precipitate. We'll draw a little arrow next to its symbol to show that it is a solid that formed and came out of solution. Okay? And then frequently we will put the state of matter in parentheses behind the molecule's chemical formula to show that it's a solid, a liquid, a gas. Or sometimes they put AQ for aqueous. It's dissolved in water. Okay? Let me show you some examples here. So we could react and say that if we have chlorine gas, that it is leaving, oh, look at that, that it is leaving, we might have to put an up arrow. My arrow's disappeared. Or if we have a solid precipitating, we put a down arrow. I don't know where my arrows went. And then we could say AQHCl, meaning that this hydrochloric acid is in solution, aqueous. It's been dissolved in water. Okay? 4 types of reactions. Synthesis reaction is something plus something else gives you the 2 things together. So hydrogen plus oxygen gives me water. That's a synthesis reaction. 2 things that were by themselves before, and now they're together. Decomposition is the exact opposite of that. I have one thing that is breaking up into 2 other things. So here I might have hydrogen peroxide, H2O2, and if I let that sit around long enough, it's going to become water and oxygen gas. So H2O2 yields H2O plus O2, and I have to balance that better, but that's the general idea. And so that's one thing becoming 2 things. That's a decomposition reaction. It's decomposing, it's breaking down. The third one is a single replacement reaction. You have a lone item and a pair, and then the lone item replaces part of the pair, and then at the end you have a pair and a lone item, but it's a different lone item. So AB used to be something and something else, and then along comes C, and C replaces B, so now A is with C and B is by itself. So you can do kind of like humorous dating things with this, right? Here this is boy meets girl, and then they wind up dating. Isn't that beautiful? And then here you have a dating couple that winds up breaking up. And notice I'm using dating because we don't want this to be marriage. Breaking up, Jesus hates divorce. But breaking up is sometimes very good with your boyfriend because sometimes he's a jerk. And then single replacement reactions would be, 2 people that are dating and they're going out, and then they go to a dance, and the guy's like, oh, she's prettier than you are. And he winds up dancing with her, and she's out by herself. Notice how I said sometimes he's a jerk. That's what's happening here. We have a single replacement reaction. They came to the dance together, but she's prettier. He now is dancing with her, and she's sitting there by the punch bowl steaming at him. It's a single replacement reaction. It gets even funnier, though, in a double replacement reaction, right, where you have 2 things that are both partnered up. So this is usually an acid and a base. And so the 2 parts of the acid and the 2 parts of the base break up in solution and react with each other, and you wind up having what used to be the first part of the acid and the last part of the base together now as a salt, and the last part of the acid and the first part of the base now together as water. And so that usually is the example in a neutralization reaction. We'll get to those later in the year. But anytime you have 2 substances that you mix together and they just change partners, that's called a double replacement reaction. And again, back to the dating thing, this would be 2 people go to the dance with their spouse. Oh, I said spouse, sorry. They're a significant other. And they wind up dating with each other's significant other. And so, yeah, dance floor drama. But that is a double replacement reaction. Okay? If you are a cartoon fan, you will appreciate this next illustration. I know I very much liked the Flintstones growing up. I'm not sure anybody here watches the Flintstones anymore, but I'm going to show this to you anyway. This is somebody else's YouTube video. It's not mine, but it will help you, I think. So I'm going to let myself become less and let this one become more. And I think you'll enjoy this. Here you go.
Chemical reactions with the Flintstones.
The Flintstones.
If Fred were to go to a dance and he were to meet Wilma,
can I close the ad in the...
Fred and Wilma would combine together and form the Flintstones. This is called synthesis.
Synthesis.
When substance A is added to substance B, and you get a combined compound of AB, you have created synthesis. Similar to when hydrogen and oxygen bond together to form the molecule water, the synthesis of water. If, however, the Flintstones were together and they got a divorce, so that Fred was on his own and Wilma were on her own, then you have decomposition.
Decomposition of marriage
A
is a terrible
compound
thing. We don't like
breaks
that.
down into its component parts. AB yields A plus B. This happens in the decomposition of potassium chlorate, when KClO3 breaks down into KCl, potassium chloride, and oxygen gas. If, however, the Flintstones went to a dance and they met up with Betty, and when Betty showed up, she ended up with Fred, leaving Wilma by herself, we would call this single replacement. We are replacing one part of the pair. So AB plus C gives off AC plus B. We are replacing one part of the compound. This is called single replacement, and this happens when silver nitrate combines with copper to create copper nitrate and release silver. And our last type of chemical reaction is a double replacement. That's if the Flintstones went to that same dance, and there they met the Rubbles. And while they were dancing, Fred ended up with Betty, while Barney ended up with Wilma. In this case, we are exchanging two partners, this being double replacement. AB compound breaks down along with CD compound, which breaks down, and you end up with compounds AD plus CB. An example of this would be a double replacement reaction where potassium nitrate combines with magnesium chloride and ends up being magnesium nitrate plus potassium chloride. This is classification of chemical reactions, and thank you to the Flintstones.
There you go. Hope that was helpful. Those little cartoons helped me when I was trying to figure out how to describe this to you, so thought I'd show it to you. God bless you. Have a wonderful day. If you have any questions, please let me know, and I will see you tomorrow. Jesus loves you, and so do I.